Welcome back. This is our second video on circular motion, and it is a continuation of our previous lesson. We will start by introducing you again to angular velocity, because in this video we would want to give you 2 or 3 formulae that are associated with angular velocity. So if we should read the definition of angular velocity, it is defined as the change in the angular displacement per change in time. So when you talk about change in the angular displacement per change in time, that is what we call angular velocity. The unit of angular velocity or angular speed is radians per second. The angular velocity is also called angular speed and angular frequency. So if we should go by the definition, it says the angular velocity is equal to the change in angular displacement divided by the change in time. So that is angular velocity is omega is equal to change in the angular displacement divided by change in time. But what do we know about the change in the angular displacement? You remember that theta is equal to S divided by R in our previous video, right? So if there is a change in the angular displacement, then obviously there will be a change in the length of the arc, right? Just try to visualize it. If the angular displacement is increasing, it means that the length of the arc will also increase. That is delta S. Remember, the radius, that is R, will remain constant if you have a body that is moving with a constant speed. So it means that the delta theta, that is change in the angular displacement, is equal to change in the length of the arc divided by the radius of the circle. So if I should substitute that into this equation, then I will have omega is equal to what is delta theta? Delta theta is delta S divided by R. Okay, so this is going to be divided by delta T. So which means omega is equal to delta S over R. For the long division, I can use the short division and say divide by change in time. So omega will be change in the arc displacement divided by R. If I want to change the division to multiplication, then that will be times 1 all over change in time. So omega is equal to delta S times 1 is delta S divided by R times delta T is R delta T. So I can do something here. If I want to make sure that delta S and delta T are just on a separate side, this is the way I can write it. Omega is equal to 1 all over R times delta S divided by delta T. I hope you understand. It's just a way of rearrangement, because 1 times delta S will give you delta S again, r times delta t will give you r delta t. So the reason why I did this is to make sure you recall something in physics. If you have displacement divided by time, that is change in displacement divided by change in time, or if you want, you can say change in distance divided by change in time, that brings something into the picture, okay? And that is velocity, okay? Or if you want, you can say speed. So, but change in the displacement divided by change in time is equal to v. So which means where I have change in displacement divided by change in time, I can replace v. That is omega is equal to 1 over r times v. So that is going to be omega is equal to 1 times v is v divided by r. So this is how you have the angular velocity being equal to the linear velocity divided by the radius of the circle, okay? So this is where actually, if you cross multiply, you will have v is equal to omega r. So I will try to bring this again when I am deriving the formula for linear velocity. But for now, this is how you prove that omega, that is the angular velocity, is equal to the linear velocity divided by the radius of the circle. Let's say the object in circular motion performs a complete rotation or revolution or even an oscillation. What will be omega then? So for a complete rotation, revolution, or oscillation. So oscillation, we will talk about that more when we are dealing with simple harmonic motion, all right? Remember, when you have a to and fro motion, okay, motion that is repeating itself, that is an oscillation. We'll talk about that. Again, going back to the definition of angular velocity, we said that angular velocity is what? The change in the displacement divided by the change in time, right? So if the object actually performs a complete rotation, let me try to bring in a diagram to help us visualize what we're trying to talk about here. So let's say this is the diagram that we have, okay? This is the circumference of a circle, and let the initial position of the object be here, okay? The center of the circle is here. If we have an object that starts its motion from this position here and it moves along the circumference of the circle to come back to its initial position, that is called a complete revolution, all right? So, or you can call it a complete rotation if at all the object is just turning around its own axis. It doesn't matter. So what will be the delta theta there? Okay, what will be the angular displacement? The angular displacement will be 360 degrees. So that will be omega is equal to, in the place of delta theta, we will write 360 degrees. Okay, divide by, for delta t, when we are talking about one complete rotation or revolution, we use the letter T, that is capital T, signifying period, okay? We will come to that later. So, but for now, what you have to understand about period is the time taken to perform one complete rotation or one complete revolution. That is called period. Okay? So, instead of delta t, I will write t. Now, moving on, omega will be equal to what is 360 degrees in terms of radians. You can recall in our previous video, we've said that 360 degrees is equal to 2 pi radians. So in the place of 360 degrees, I can write 2 pi. So that is how the 360 degrees will change to 2 pi, then over t. So this is also a formula for the angular velocity. The angular velocity is equal to 2 pi divided by the period. So omega is the angular velocity, t is the period. All right, so that is the relationship between the angular velocity and the period. But you should also know that the period is the inverse of the frequency. We will discuss all of this subsequently. But one thing you have to know what frequency is. It is the number of complete cycles in 1 second, okay, or in a given time. So how many times has the object rotated or performed revolution around the circle in just 1 second? That is called the frequency. All right, frequency is the number of times an object performs a complete rotation or a complete revolution in 1 second. So if that is the case, it means we can have from this formula omega is equal to 2 pi divided by period will be 1 over f. So we can rewrite this as omega is equal to 2 pi divided by 1 over f. So omega will be equal to 2 pi. If I want to change the division to multiplication, that will be times the inverse of 1 over f will be just f. So this is how omega is equal to 2 pi f. So that is what we have for you on the angular velocity. You should know that angular velocity omega is equal to v all over r. You should know that the angular velocity omega is equal to 2 pi divided by the period, and you should also know that omega is equal to 2 pi f. So these three formulae are important, all right? You should be able to know how to apply it. In the question, if you are given the frequency and you are asked to find the angular velocity, it's just 2 pi times that frequency. In the question, if they give you the period, it's just going to be 2 pi divided by the period to be able to have the angular velocity. If at all they give you the velocity or the speed of the object with the radius of the circle, then by dividing the velocity by the radius of the circle, you will be able to have the angular velocity. Okay, that is all what we have for you for angular velocity. We are now moving on to discuss linear velocity. Linear velocity is the velocity of the object that is tangent to the circumference of the circle. Okay, the linear velocity is the velocity of the object that is tangent to the circumference of the circle. It is the distance traveled along the circumference per unit time. You can define it this way if you want. It is the product of the angular velocity and the radius of the circle. So let's try to master these definitions very well. It says it is the distance traveled along the circumference per unit time. That is the linear velocity. So it means you can have the velocity as the distance traveled along the circumference is s divided by time. So this is going to be a formula for linear velocity. But it also says here that the linear velocity is the product of the angular velocity and the radius. So for now, these are the two formulae that you have to familiarize yourself with. So one thing that is important for you to know is that the linear velocity can also be called the linear speed, the tangential speed, and the tangential velocity. The word tangential there is important because it tells you the direction of the linear velocity with respect to the circumference of the circle. So if this is the circumference of the circle, and let's say we have the object that is positioned here, the velocity is going to be tangent to the circumference of the circle. What that means is that the line will touch the circumference or the curve at just a single point. So this is how you're going to have the line to demonstrate the tangential velocity. Okay, so that is a tangent. So this is how you draw the tangential speed or velocity. It will touch the curve at only a single point. Okay, that is what a tangent means if you know mathematics. Always try to remember the direction of the velocity. It is always going to be tangent to the curve. All right, you can be asked to draw that in some examination papers. All right, they can ask you the direction of the velocity, that is the linear velocity, the direction of the centripetal force, the direction of the centripetal acceleration. For the centripetal force and acceleration, we will come to that, but know that the direction will always be towards the center of the circle. Okay, so how will we be able to prove the formula for linear velocity? That is, we want to prove that v is equal to omega r. That is, the linear velocity is equal to the angular velocity multiplied by the radius of the circle. Again, a formula that is always important to start with. We know that the angular velocity is equal to change in the angular displacement divided by the change in time. So we know that delta theta is equal to delta s divided by the radius of the circle. That is, change in the angular displacement is equal to change in the length of the arc divided by the radius of the circle. So if we substitute that into this equation, we're going to have omega is equal to change in the length of the arc divided by r all over change in time. So omega will be equal to change in the length of the arc divided by r. So if we want to use the short division sign, we can say divide by delta t. So omega is equal to delta s all over r times 1 all over delta t. That is, if we want to change this division sign to multiplication, the delta t will be inverted. So omega is equal to delta s all over r delta t. Unlike we have previously said, we can divide this as 1 all over r times delta s all over delta t, where delta s all over delta t is equal to the velocity v. So therefore, omega is equal to 1 all over r times v. So omega is equal to v all over r. So what we just have to do is to cross multiply. If we cross multiply, v becomes omega r. So this is how you prove that the linear velocity is equal to the angular velocity multiplied by the radius of the circle. But let's say someone would want to have a different approach, okay, using speed is equal to distance over time. You don't have to do all the methods. I'm just trying to do this so that you can actually familiarize yourself, know at least which of the formula could work for you. All right. So that is why it might seem to be a repetition for you, but I'm just begging on your patience to be able to grab what I am trying to give you. To have v is equal to omega r, we can use speed is equal to change in distance divided by change in time. That is, speed is equal to change in s divided by change in t. But if you can remember previously, we've said that delta theta is equal to delta s divided by r. So in that case, if at all I want to find delta s, it will be equal to r delta theta, right? So it means in the position of delta s, I can substitute r delta theta into this equation. So that will be v is equal to delta s will be r delta theta divided by delta t. And again, if you can remember previously, we've said that the angular velocity is equal to change in the angular displacement divided by change in time. I think you can remember this. So if at all I want to find change in the angular displacement, that will be omega times delta t. So which means in the place of delta theta, I can replace omega delta t. So let's try to substitute that into this equation here. That will be v is equal to r. What is delta theta? Delta theta is omega delta t. So this will be divided by delta t. So you can see how delta t can cancel delta t. So what are we left with? We're going to have v is equal to r omega, or if you want, you can say v equals to omega r. Okay, so any of the method is okay. All right, so just know which one will work out for you if you want to prove that v is equal to omega r. V is the linear velocity or speed. Remember that omega is the angular velocity and r is the radius of the circle. So we want to consider a situation where the object performs one complete rotation or oscillation or revolution. So let's try to see what we can get from that. For a complete rotation, or you can call it revolution or oscillation, it doesn't matter. If we use V is equal to change in the displacement divided by change in time, so for a body that performs a whole circle or one complete rotation, the length of the arc becomes the whole length of the circumference. So which means delta S becomes 2 pi r, right? Divided by the delta T here will now be changed to period, okay? That is the name or the time that we use when the object performs one complete rotation. So instead of delta T, we will use capital T, that is the period, meaning the time it takes for a body to perform one complete rotation or revolution. So this is how you have the formula V is equal to 2 pi r divided by the period. But we also know that the period is equal to 1 all over f. Do you remember that? Yes. So in terms of frequency, how do I write that into this equation? So that will be V is equal to 2 pi r divided by 1 all over the frequency. So V will be equal to 2 pi r divided by 1 over f if I want to write it this way. So to change the division sign to multiplication, I will have to invert this. So that is going to be 2 pi r f. Okay, or if you like, you can say 2 pi f r. So this is the formula for the linear velocity. So to summarize, we said that V is equal to omega r. We said that V is equal to 2 pi r divided by t. We said that V is equal to 2 pi f r. Moving on to time. What is time? Time is the total duration or how long an event takes place. So if you are talking about circular motion, you are talking about the duration of the circular motion. So time is measured in seconds. But I will want to take my time here to emphasize that small letter t is for time and capital letter T is for the period. Okay? The time here is talking about the whole duration. Okay? The whole duration. That is for the small t. The capital letter T is just talking about the time it takes to perform just one rotation or just one revolution. Okay? So remember, there is a difference. All right? So let's say the body performs 60 revolutions in 20 seconds. So that 20 seconds is for this time. Okay? It is the whole duration. The body performs 60 revolutions in 20 seconds. But if you want to know, out of those 60 revolutions, how many revolutions have been performed in just 1 second? That is called the period. Okay? That is called the period. So you should now know that the time, that is the whole time, is equal to the number of rotation or the number of revolution multiplied by the period. Okay? It makes sense. If I want to know the period, that is, I'm going to divide both sides by n, okay, such that the period becomes the total time divided by the number of oscillations or revolutions. So again, please know that the time, that is the total time, is equal to the number of rotation or the number of revolution multiplied by the period. Okay? And you should also know that the total time is equal to the number of rotation or revolution divided by the frequency. That is, if at all we are given frequency. Again, if we use T is equal to the number of rotation or the number of revolution multiplied by the period, but we know that period is equal to 2 pi divided by omega. This is from the formula, if you can recall, omega is equal to 2 pi divided by the period. So it's just a change of subject or change of subject. So if omega equals to 2 pi divided by t, if you want to make t the subject of the formula, t becomes 2 pi divided by omega. That is how we came to this point, okay? Do not be confused. So that is, we can have t is equal to n into 2 pi divided by omega. So that is t is equal to 2 pi n divided by omega. So that is the total time is equal to 2 pi n divided by omega. To summarize what I have just said, we have the time is equal to the number of rotation or revolution multiplied by the period. We have the time is equal to the number of rotation or revolution divided by the frequency. We also have time is equal to 2 pi n divided by the omega. Okay, so try to remember at least one of these formulae. So when we talk about time, we're talking about the entire duration. Remember that? But when we talk about the period, we are talking about the time it takes to perform just one complete rotation or revolution. There is a difference there. So try to understand that. Moving on to the period, we have already defined that. It says it is defined as the time taken by an object to complete one circular orbit or rotation. So the word one here is very important. The time taken to perform just one oscillation or just one rotation or just one revolution, that is what we call period. We have some conversions for you here. If at all you have time in minutes, you want to convert it to seconds, you just multiply that by 60. If you have time in hours, you want to convert it to seconds, you just multiply it by 3600. To just remind ourselves again that from t is equal to the number of rotation or revolution multiplied by the period. If you want to find period, it means period is equal to t divided by n. So you can get it this way, that the period is equal to the total time divided by the number of rotation or the number of revolution. Okay, so we will consider a circumstance, that is when a body performs a complete rotation or revolution. So if you remember, we said omega is equal to delta theta divided by delta t. And we said that if the object is to perform one complete rotation, the angular displacement there will be 360 degrees, and therefore the time is now changed to period. So I think this is understood. So if we cross multiply, we'll have omega times the period is equal to 360 degrees. So if I want to find the period, I will divide both sides by omega. So it means that the period is equal to 360 degrees divided by omega. But what is 360 degrees? We said that is equal to 2 pi. So therefore, we'll have period equals to 2 pi divided by omega. So this is how you can get that. All right. And you should also know that the period is the inverse of the frequency and vice versa. Okay. The frequency is the inverse of the period. The period is the inverse of the frequency. This is something that you always have to remember. The number of rotation. So this is just like a repetition of what we have said. You should know that from frequency is equal to the number of rotation divided by the time. Okay, this is how you find the frequency. It is always the number of rotation divided by the total time. So from that, it means if at all we want to find the number of rotation will be equal to frequency multiplied by the whole time. Okay, and also you should know that the number of rotation is equal to the total time divided by the period. These two formulae are important to remember. And finally, we are at frequency. What is frequency? It is defined as the number of complete rotation made in a unit time. Usually, we just want to know the number of complete rotation in 1 second. Okay? So when you talk about the number of complete rotations or the number of complete revolutions made in just 1 second, that is called the frequency. Okay? The unit of frequency is hertz, or you can say per seconds. Frequency is inverse of the period. We have already said that. All right? So to remind ourselves again, frequency is the inverse of the period, and we know that frequency is equal to the number of rotation divided by the time. Okay? And if we should use the first formula, that is frequency is equal to 1 all over the period, but we know that the period is equal to 2 pi divided by the omega. So that is going to be F is equal to 1 all over 2 pi over omega. So that is going to be 1 divided by 2 pi over omega, right? So if I want to change the division to multiplication, that will be 1 times omega will go up, divided by 2 pi will come down. So that is how frequency is equal to omega divided by 2 pi. So that is all for today. In our next video, we will discuss about centripetal force and centripetal acceleration. I know we have derived a lot of formula here, but that is circular motion. So what I will advise you to do is to be going over this video maybe 2 to 3 times, and always try to write for yourself so that you can be familiar with it, and with time you will not have difficulty in remembering all these formulae. So if this is the first time of visiting this channel, please subscribe to the channel, like and share our videos. See you soon.